GMAT all day.
This final video is an optional bonus video. We will be talking about collision problems or collision rate problems. The only reason I have called this a bonus video is because I do not see these all that often, certainly not as much as other types of rate questions, such as additive rate questions, but I have seen them before. And so I do think it is worth watching this video. And so these are sort of the classic standardized test question where you have two things coming at each other. It is almost always trains, but I suppose it can be anything. Then you want to know either at what point do they meet or at what time do they meet. And so the only thing to know for these questions is this concept here, and I'll show it first and then we can walk through it. And so the only thing new that you need to know, everything else is just going to be the same sort of rate knowledge we've been learning this whole time. The thing to know for these questions, though, is the time when the two trains meet is going to be equal to the time for a single train to travel the entire distance at their combined rate. And so let's go through what this is saying and why this is. So say we have two trains. Yeah, this one, he leaves from station A, and this guy leaves from station B. And they meet here. And so let's say if they leave at the same time, and this train is traveling at 60 miles per hour, this train is traveling at 20 miles per hour, so it makes sense. When they meet, this guy will have traveled further than this guy over here, and then they meet at this point here. So what do we know about this point here? Well, between them, how far have the two trains traveled when they meet? So between them, they have traveled the entire distance. So let's say the distance between our two towns is 100 miles. So at this point here, where they meet, our two trains have covered the entire distance, the entire 100 miles from A to B. At what rate did they do that? Well, each of our two trains is contributing to the closing of this gap here. So it is sort of as if they covered this 100 miles at a rate of 80 miles per hour. And so that is what we mean when we say the time where the two trains meet is equal to the time for a single train to go the entire distance from A to B, but at a rate of 80 miles per hour. And so if we want to find the time where these two trains meet, we can just say that time here, there we go, is going to be the same as going to be the same time as the time for a train to go the entire 100 meters at a rate of 80 miles per hour. The time would be 100 over 80, which is 5/4 of an hour. So let's see a question similar to this, an actual GMAT format. Now, the one thing this assumes is that the two trains leave their stations at the same time. So if they didn't tell you that, if there was a delay, for instance, you would have to take that into account when answering the question. Our question here says, the path from town A to town B is a straight line. An express train can travel the 150 miles between town A and town B in 1 hour. A regular train can travel the same distance in 1.5 hours. If the express train leaves from town A or town B at the same time, that the regular train leaves from town B towards town A, so they leave at the same time, so there's no delay. How much further will the express train have traveled than the regular train when the two trains meet? And so here we have a very similar situation to before. So I try to make my diagrams as accurate as possible. So if one of our trains is the express train and he is traveling faster, he should be going a further distance. So I want to make his arrow longer. This is the express train. This is the regular train. And so what do we know? We know we have 150 miles between our two towns. And our express train, he can go the 150 miles in 1 hour. So his rate is 150 miles per hour. Now the regular train can travel 150 miles in 1.5 hours. So his rate is 150 miles per 3/2 of an hour, which means his rate is 150 times just 100 miles per hour. Yeah, makes sense because the regular train should be going slower than the express train. So then we want to know how much further will the express train have traveled than the regular train when the two trains meet. So we just got to find their individual distances that they traveled when the trains meet and then subtract them. So to find this time, the time when they meet, what do we do? Well, it is the same as the time for a single train going at their combined rate, the full distance. And so that would be a single train traveling at a rate of 250 miles per hour, going the full 150 miles. So the time is equal to the time for a train going at their combined rate of 250 miles per hour to travel the entire distance from A to B, which is 150 miles. So time is 150 over 250, which is 15 over 25, which is divided by 3/5 of an hour. So they're not asking for the time. As the time when the two trains meet, we want to know how much further the express train has traveled. So for that, we do another. So the time where the two trains meet, so the time should be the same for each of our two trains. They each traveled for 3/5 of an hour, except our express train traveled at 150 miles per hour. Our regular train traveled at 100 miles per hour. So the distance that our express train traveled is going to be 90 miles. The distance that the regular train is going to be 20 times 3, which is 60 miles. So note that between them, this is the distance each train traveled when they meet, and between them, they traveled 150 miles, which is the entire distance from A to B. So this checks out. And we want to know how much further the express train traveled. So that is just 90 minus 60, or 30 miles.